Welcome. Today we're diving into the world of effective data design. Whether you're building a new application, managing a business, or simply curious about how information is structured, understanding data design is essential. In this video, we'll explore the principles, strategies, and best practices that lead to robust, scalable, and efficient data systems. Let's start by defining what data design really means and why it's so important in our digital age. From databases to analytics, good data design is the foundation for reliable decision-making and seamless user experiences. Data design refers to the process of structuring and organizing data so it can be efficiently stored, accessed, and used. It's about making sure information flows smoothly between systems and users. Effective data design considers how data is collected, how it relates to other data, and how it will be retrieved or updated. This process is crucial for everything from small spreadsheets to massive enterprise databases. By focusing on data design, organizations can avoid redundancy, improve performance, and ensure data integrity. Imagine trying to find a single file in a messy office. That's what poor data design feels like. Effective data design streamlines information, making it easy to locate, update, and analyze. It reduces errors, saves time, and supports better business decisions. In today's data-driven world, companies rely on well-designed data systems to stay competitive. Whether you're managing customer records or analyzing sales trends, good data design ensures your information is accurate, secure, and accessible. The heart of effective data design are several core principles. These include consistency, accuracy, scalability, and security. Consistency ensures that data is uniform across all systems. Accuracy means the data truly reflects reality. Scalability allows your data system to grow with your needs, and security protects sensitive information from unauthorized access. By following these principles, you lay a strong foundation for any data-driven project. Data model is a blueprint for how data is structured and related. There are several types of data models, including conceptual, logical, and physical models. Conceptual models outline the high-level structure, logical models add more detail, and physical models describe how data is stored in databases. Choosing the right model helps ensure your data is organized and accessible, no matter how complex your system becomes. Conceptual data modeling is the first step in designing a data system. Here you focus on the big picture, what entities exist and how they relate to each other. For example, in a library system, you might have entities like books, authors, and members. At the stage, you're not worried about technical details, just the overall structure. This helps stakeholders understand and agree on what information needs to be captured. So you have a conceptual model. It's time to get more detailed with logical data modeling. Here you define the attributes of each entity and the relationships between them. For instance, a book entity might have attributes like title, author, and ISBN. Logical models help you identify how data will be organized and how different pieces of information connect, without worrying about how it will be physically stored. Physical data modeling translates your logical model into a real database structure. This is where you decide how data will be stored, indexed, and accessed in your chosen database system. You'll define tables, columns, data types, and constraints. Physical modeling ensures your data system is efficient and optimized for performance, making it easier to handle large volumes of information. Normalization is a key technique in data design that helps eliminate redundancy and improve data integrity. By organizing data into related tables and defining clear relationships, normalization ensures that each piece of information is stored only once. This makes updates easier and reduces the risk of inconsistencies. While normalization can make databases more complex, it's essential for maintaining clean, reliable data. While normalization is important, sometimes denormalization is necessary for performance. Denormalization involves combining tables or duplicating data to speed up queries. This can make certain operations faster, especially in large databases. However, it also increases the risk of data inconsistencies, so it should be used carefully and only when performance gains outweigh the drawbacks. Selecting appropriate data types for your fields is a fundamental part of data design. Using the right data type, such as integer, string, or date, ensures that your data is stored efficiently and accurately. It also helps prevent errors and improves query performance. Always consider the nature of your data and choose types that best fit your needs. Primary key is a unique identifier for each record in a table. Defining primary keys is essential for maintaining data integrity and enabling efficient data retrieval. Good primary keys are unique, stable, and simple. They help prevent duplicate records and make it easier to link related data across tables. Foreign keys establish relationships between tables by linking a field in one table to the primary key of another. This enforces referential integrity, ensuring that related data stays consistent. For example, an orders table might have a customer-id foreign key that links to the customers table. Proper use of foreign keys is crucial for building reliable, interconnected data systems. Indexes are special data structures that speed up data retrieval. By creating indexes on frequently searched fields, you can make queries much faster. However, indexes also require additional storage and can slow down data updates, so it's important to use them wisely. Effective indexing is a balance between performance and resource usage. Data integrity means that your data is accurate, consistent, and reliable. This is achieved through constraints, validation rules, and careful design. For example, you might require that email addresses follow a specific format or that certain fields cannot be left blank. By enforcing data integrity, you ensure that your information remains trustworthy over time. Null values represent missing or unknown information. Deciding how to handle nulls is an important part of data design. Sometimes, it's better to use default values or require that certain fields are always filled. Clear policies for null values help prevent confusion and ensure your data remains meaningful. Protecting your data from unauthorized access is a top priority. Effective data design includes security measures like access controls, encryption, and regular audits. By planning for security from the start, you reduce the risk of data breaches and ensure compliance with regulations. Always consider who needs access to what data and implement safeguards accordingly. As your organization grows, so does your data. Scalability means designing your data systems to handle increased volume and complexity without sacrificing performance. This might involve partitioning data, optimizing queries, or choosing scalable database technologies. Planning for scalability ensures your system remains efficient as demands increase. Data redundancy occurs when the same information is stored in multiple places. While sometimes necessary for performance, redundancy can lead to inconsistencies and wasted storage. Effective data design minimizes unnecessary duplication, ensuring that updates are made in one place and reflected everywhere. This keeps your data clean and reliable. Good documentation is a hallmark of effective data design. Data dictionaries describe each field, its type, and its purpose. This makes it easier for developers, analysts, and stakeholders to understand and use the data correctly. Keeping documentation up to date ensures that everyone is on the same page and reduces the risk of errors. One-to-one relationships link a single record in one table to a single record in another. For example, each employee might have one unique ID card. Understanding and correctly implementing these relationships ensures data is organized and prevents unnecessary duplication. One-to-many relationships are common in data design. For instance, one customer can place many orders. This structure allows you to efficiently organize related data and retrieve it as needed. Properly defining these relationships is key to building flexible and scalable systems. Many-to-many relationships occur when multiple records in one table relate to multiple records in another. For example, students can enroll in many courses and each course can have many students. These relationships are managed using junction tables, which help keep data organized and accessible. Data relationship diagrams, or ERDs, are visual tools that map out the structure of your data system. They show entities, attributes, and relationships, making it easier to design and communicate your data model. ERDs are invaluable for planning and troubleshooting complex data systems. Data flow diagrams illustrate how information moves through your system. They help identify sources, destinations, and processes that handle data. By mapping data flows, you can spot inefficiencies, bottlenecks, or security risks, leading to better system design. Data validation ensures that only correct and meaningful data enters your system. Techniques include format checks, range checks, and consistency checks. By validating data at entry, you prevent errors and maintain high-quality information throughout your system. Data migration involves moving data from one system to another. Effective data design makes migration smoother by ensuring data is well-structured and documented. Planning for migration from the start helps avoid data loss and minimizes downtime during transitions. No data system is complete without a solid backup and recovery plan. Regular backups protect against data loss from hardware failures, human error, or cyberattacks. Effective data design includes strategies for quick recovery, ensuring business continuity even in the face of disaster. Archiving involves moving old or infrequently used data to long-term storage. This keeps your main system fast and efficient while preserving important information for future reference. Effective archiving strategies balance accessibility with storage costs and compliance requirements. Privacy by design means considering data privacy from the very beginning of your project. This includes minimizing data collection, anonymizing sensitive information, and complying with regulations like GDPR. By embedding privacy into your data design, you build trust with users and avoid costly legal issues. Master Data Management (MDM) is the process of creating a single, consistent view of key business data. MDM ensures that everyone in the organization is working with the same, accurate information. This reduces errors, improves decision-making, and supports business growth. Data governance frameworks define policies and responsibilities for managing data assets. They ensure data quality, security, and compliance across the organization. A strong governance framework supports effective data design by providing clear guidelines and accountability. Metadata is data about data. It describes the structure, meaning, and usage of your data assets. Effective use of metadata makes it easier to find, understand, and manage information. It's a key part of any well-designed data system. Maintaining high data quality is essential for effective data design. This involves regular checks for accuracy, completeness, and consistency. Automated tools can help monitor data quality and alert you to issues before they become problems. Data lifecycle management tracks information from creation to deletion. Effective data design considers how data will be created, used, archived, and eventually removed. This helps control storage costs, maintain compliance, and ensure data remains relevant. There are many tools available to help with data modeling, from simple diagramming software to advanced database design platforms. These tools make it easier to visualize, document, and implement your data models, saving time and reducing errors. Effective data design is a team effort. Collaboration between developers, analysts, and business stakeholders ensures that all requirements are understood and met. Open communication and regular feedback lead to better, more usable data systems. Agile methodologies can be applied to data design, allowing for iterative development and continuous improvement. By breaking projects into smaller pieces and regularly reviewing progress, teams can adapt to changing requirements and deliver better results. Even experienced designers can make mistakes. Common pitfalls include poor documentation, lack of normalization, ignoring scalability, and weak security. By being aware of these issues, you can avoid them and create more effective data systems. Let's look at a real-world example. In e-commerce, effective data design means organizing products, customers, orders, and payments efficiently. This allows for fast searches, accurate inventory tracking, and smooth checkout experiences. A well-designed data system supports business growth and customer satisfaction. In healthcare, data design must balance accessibility with privacy and compliance. Patient records, appointments, and billing information need to be organized for quick access while protecting sensitive data. Effective design improves patient care and supports regulatory requirements. Data design is constantly evolving. Trends like cloud databases, big data analytics, and artificial intelligence are shaping how we structure and use information. Staying up to date with these trends helps you design systems that are future-proof and competitive. Analytics relies on well-designed data systems to provide insights and drive decisions. Effective data design ensures that information is accurate, timely, and easy to analyze. This empowers organizations to make data-driven choices and stay ahead of the competition. Data design is not a one-time task. Continuous improvement means regularly reviewing and updating your data systems to meet changing needs. This includes monitoring performance, gathering feedback, and implementing new technologies as they become available. Wrap up: effective data design is the backbone of any successful digital system. By following best practices, staying informed about new trends, and focusing on quality, you can build data systems that are robust, scalable, and ready for the future. Remember, great data design leads to better decisions, happier users, and stronger organizations. Thanks for joining us on this journey through the essentials of effective data design.